ಬಂದಿದ್ಯಾ? ಎಲ್ಲ ಬಂದಿದ್ಯಾ? ಓಕೆ, ರೈಟ್. ಮಾಡ್ತಾರೆ ರೈಟ್. ಸಾರಿ, ನಾವು last class we have discussed about microprocessor based controllers, right? And then we understood about the two different programming methods, embedded microcontroller method and PLC method, and went about sequential controllers and an example of sequential controller, which is an automatic washing machine. Okay, so this was what we had done in the last class. Shall we proceed?
Yes, sir.
Yeah, okay, right. Now,
Yes, sir.
the second sequential controller, example of sequential controller, or the example for a microprocessor based controller is what was called as automatic camera. Okay, right. Now just observe this carefully, and we'll try to understand some of the components of which, and then we'll discuss. Okay, so this automatic camera is an example for microprocessor based control system. Okay, it's an example for microprocessor based control system. It's also basically all the microprocessor based controllers obviously should work on the sequential control system only. That is, one after the other it is going to work. Okay, right. So before we go further, now we'll try to understand what are what is the aspect of automatic camera. Okay, in this automatic camera, what we expect is the light intensity should be adjusted, and the movement of the lens should be adjusted depending upon the image that you need to take, and the loading and unloading should occur in an automated manner. Okay, right. Before we go further, we'll try to understand some of the components here. Okay, so in automatic camera we have some of the components. We'll just try to understand some important components. Okay, we have what is called as range sensor. Okay, so what is this range sensors? Any idea what for it is used? We'll understand the component first, and then we'll understand the working of this automatic camera with the explained components. Okay, right. What is range sensor? Any idea? Hello?
Like for example, it is the temperature sensor.
No, range sensor.
So up to that range only it will catch the signals.
Okay, means it is what? It is with respect to what parameter? Range sensor is
Distance.
with respect to what parameter?
So
Distance, sir.
distance.
Distance. Okay, exactly. Okay, range sensor basically is a type of the sensor which senses the distance of the object to be photographed. Correct? Okay, because now I am holding an automatic camera with me. Now, what is that I am capturing? Okay, the distance between my lens and that object is what is called as the range sensor. And that means that distance is going to be detected by using what is called as the range sensor. Okay, that is what you mean by range sensor. Then, what is the purpose of light sensor here? Remember, light sensor is going to be used to understand what is the intensity of the light to the microprocessor. Means now just observe. Now I am over here. Okay, I am going to capture an image. I'll know what is the distance of the image to me. Okay. If the distance is too larger, the light intensity is going to vary. Correct or what? Okay, the distance is there and light intensity. That means where are you taking the photograph? Okay, in whether are you going to take the photograph on a broad light outside your room, or is it inside the room, or what is the or are we taking a mountain picture? Okay, now that depends upon what is the amount of light intensity is going to be measured by using light sensor. First is range sensor. Range sensor measures the distance of the object to be photographed. Light sensor is the one which gives a signal regarding the intensity of light. Okay, light intensity on the object to the microprocessor. That means now what is the amount of light which is falling on that particular object? Okay, is sensed by the light sensor. Okay, then those are the two sensors. Then there is one more sensor present here called as the encoder. Okay, what do you mean by encoder? Any idea? Encoder? Encoder, okay, remember, encoder is nothing but, okay, which is a if you observe, the lens has to rotate depending upon the what? Depending upon the focal length. That means just observe, just a simple observation. If the object to be photographed is very in front of you, correct na? If the object to be photographed is very in front of you, the lens need not to be rotated for a longer duration. Yes or no? Yes or no?
Yes, sir.
Okay. If the object is too far from you, if the object is too far from you, can you use the same lens position that you have used earlier?
No, sir.
No. Okay. That means lens position has to be adjusted. Now, once the lens is going to rotate, I should know what is the amount that I have rotated. That depends upon what? The adjustment of the lens depends upon what? First it should depend upon the how far. How far? Are you understanding?
Yes, sir.
Yes or no?
Yes, sir.
It should depend upon how far the object is. Okay, is the object is very nearer to you, or is the object is away from you? Depending upon that, you are going to adjust the lens. Okay, this adjustment is going to happen in an automated manner. Okay, so that is what is called as the encoder. Encoder is used to know what is the rotation that you have made. Okay, encoders are the devices. Remember, in detail we are going to do that later actually. So as of now, remember, encoders are the devices which are used to know what is the rotation that you are given to any rotating object. Okay, any rotating object. In this case, the rotating object is nothing but the lens rotation. The rotation of the lens, how much it is rotated, that is given by the encoder. Okay, right. That is one thing. Next is we have what is called as a solenoid. Okay, what do you mean by solenoid? Now here this motor drive, all these are called as what? Can you say what is this all about? Any idea? Motor drive, solenoid, again solenoid, lens position drive, aperture control drive. And what parameter we can classify this? What are these? Can you say?
Actuator.
Yes, exactly. Okay, these are called as the actuators. Okay, motor drive is an actuator. That's a motor is an actuator. Solenoid is an actuator. Means I need to rotate the lens. That is called lens position drive. Then aperture control drive. That again an actuator. Okay, all these are the actuators. Okay, right. Now, solenoid is again an actuator, which is going to be called as electrically actuated one. That means when an electric current has passed to the solenoid, okay, now depending upon the amount of magnetic flux density, it takes the movement. Okay, now with this, we'll try to understand how the the automatic camera is going to work. Okay, right. Now, if you understand the modern automatic cameras, generally the modern automatic camera will have the automatic focusing and the exposure. Okay, that is automatically it need to focus, and the what is the amount of exposure it is required, that it is going to take it automatically. Okay. Now, whatever the figure you are observing, okay, it shows the this is the basic concept of a automatic camera, which is going to be controlled by what is called as a microprocessor based system. Okay, for the purpose of the proper focusing and for the purpose of proper exposure. Okay, right. Now, how it is going to actually occur? Okay. Now, what are we going to do? Now, I need to take a photograph of an object. Okay. Now, at that particular moment, the switch is pressed, which activates the system. Okay, now I'm just starting from here. Okay, now just observe. Switch to activate the system. Okay, I have pressed the switch to activate the system. Now, when I switched on the to activate the system, now I have a motor drive, okay, which is going to be used for what? To advance the film. Okay, now assume that okay, assume that one second, please. ಸರ್ ಕ್ಲಾಸಲ್ಲಿ ಇದ್ದೀನಿ ಸರ್ ಒಂದೆರಡು ನಿಮಿಷ ಸರ್ ಕ್ಲಾಸಲ್ಲಿ ಇದ್ದೀನಿ ಓಕೆ ರೈಟ್ ನಾವು ಅಸ್ಯೂಮ್ ದಟ್ there is a motor drive. Now you actuate the motor drive and motor drive will advance the film to the next roll, let us say. Okay, then now shutter button pressed when photograph is to be taken. That means what? Whether I am checking what here? I have switched to activate the system. Then I am checking whether the shutter is opened or not. Okay, now for that I am going to check whether the shutter is automatically opened or not. Obviously, before I wish to take any photograph, the shutter has to be opened. That is that I am checking, and also I am checking the initial battery test. Now these three are the initial tests that you are going to carry out in order to start the system. Okay, right. Now you are into what? Now you are into actual gathering taking the image. Okay, now at this time, what is that has happened? There is a range sensor. Now what the microprocessor takes now? This microprocessor will take the input from the range sensor. Okay, what input the microprocessor will have now? What input the microprocessor will have?
Distance.
Okay, now the microprocessor will understand what is the distance that I am capturing. Okay, depending upon the distance. Okay, now what the microprocessor will gives the output? The microprocessor sends an output to what? To the lens position drive. Are you understanding? Now the microprocessor has received the input from the range sensor. This information is regarding what is the amount of distance of the object that you have photographed. Now the output will be given to the lens position drive. Then what lens position drive will do? It will move the lens. Okay, the lens position drive will move the lens. Okay, by having a motor, so that it's going to adjust whether the actual focusing can be done. Okay, whether the exact focusing can be done. Are you understanding? Right? Yes or no?
Yes, sir.
When it is rotating, when the lens is moving, I need to know how much the lens has moved. Are you understanding? How to measure the movement of the lens? Which is going to be used to measure the movement of the lens? Encoder, exactly.
Encoder.
The microprocessor has given the command to the lens to move. Okay, the lens position to move. Now, by using motor, the lens position has started to move. Therefore, I should have one more device which is going to be used to measure the position of the lens. That is done by using what is called as an encoder. That is, the position of the lens, okay, is been fed back to where? The position of the lens has been fed back to the microprocessor, which is measured by using what is called as the encoder. Okay, then now what is going to happen now? With this, you are going to adjust. Okay, the microprocessor will adjust. Microprocessor will check whether a proper movement of the position has been done depending upon the information given by the range sensor. Now you can understand the range sensor. If the object is nearer, the lens position drive rotation should not be that much required. If the object that you are photographing is larger, then you require the lens to move for a longer duration of time. Okay, right. Then after that, what is that required now? You know the distance. Next thing is the enough amount of light intensity is present on the object to be photographed? Yes or no? That is that you need to check. That is whether a good amount of lighting is present. Okay, whether a good amount of lighting is going to be present, that you need to check. So that information, from where are you going to get? That information to the microprocessor you are going to get from the light sensor. Okay, so the light sensor sends the signal of, right? The light sensor sends what? Sends the light intensity signal, okay, which is falling on the object to the microprocessor. Okay, right? Now the microprocessor will use the signal to the aperture control drive. Okay, aperture control drive, so that it adjusts slowly, okay, by using a stepper motor, so that the light intensity is going to be adjusted. Now what is that I have done now? Depending upon the range sensor, I have moved the lens position drive and I have checked the focal length, and by depending upon what is the information that I have got from the light sensor, the aperture control drive is going to move, so that enough amount of the light intensity is going to be is present on the object. Okay, now after this everything is set. Now then what is that you are observing? You are observing the display of the data in the viewfinder. Okay, in the on your the observation monitor, you are going to observe whether the display is correct or not. Okay, when it is there, then automatically you are going to click on the image, click on the object, okay, that you wish to photograph. Okay, after that what is going to happen? Then you give a motion to the motor drive, so that you will advance the film to take the next photograph. Okay, now this is what is called as the objective of what is called as an automatic camera. Okay, that means I'll repeat again. Now in case of an automatic camera, first you will be having a switch. Switch is an actuator used to activate the system. Then you have a motor drive to advance the film. This advancement of the film is required in order to take the subsequent photos. Okay. Then before you are going to start the activity, you need to check whether the shutter has been opened or closed. Okay. So now if it is closed, there is going to be an actuator to open the shutter, and then you need the shutter also to be closed after the photography has been completed. Okay, right. Then we have three different sensors which are going to be present. Range sensor. Interface circuitry means what basically? What is interface circuitry means? What is this? Any idea? Can you say? What is this? What is interface circuitry means? Which element of the measurement system is called interface circuitry?
Microcontroller.
No. Listen carefully. Which element of the micro measurement system? Which element of the measurement system is called as interface circuitry? How many elements are there in measurement system, first of all? Measurement system, how many elements are there? Oh, you already forgot that. Okay, you have sensor. After the sensor,
Signal conditioning.
signal condition. After the sensor, you have signal conditioning. Then you have display. Okay, interface circuitry is nothing but interface circuitry. Okay, which is the one which is generally called as the signal conditioning devices. Okay, right. Now you have the range sensor. The range sensor is going to give what is called as a distance. Okay, what is the amount of distance which is going to be present? Okay, that is called as the range sensor. Okay, right. So now by understanding, once again. Okay. By understanding the range sensor, I can able to know what is the amount of the distance which is going to be present. Okay, that is called a range sensor. Then we have what is called a light sensor, which is going to be used to understand what is the intensity of the light. Then the lens position drive will be moved in order to adjust the distance effectively. Aperture control drive is going to be used in order to adjust the light intensity. Okay. So with this, you are going to capture the object and will go for the next filming of the events. Okay, now this is a simple example for what is called as an automatic camera. Okay, right. Then we'll have one more example. Okay, and then we'll finish it off. That is called as engine management system. Okay, any idea about this? What do you mean by engine management system? What for it is used? Engine management system is used for what?
Controls the fuel flow and ignition time.
Yeah, okay. Now basically, engine management system is mainly responsible for managing what? For managing the ignition and fuel requirement of the engine. Okay, now I need to manage the ignition timing and the proper entry of fuel into the engine for me to get a better power stroke. Okay, now for this, how it is going to be done? Okay, now you can observe clearly. Now, before we go further with the engine management system, what is this? Can you just tell me what is this diagram? What it is indicating?
Four
Tell me, what is
strokes.
it? Huh?
4 strokes.
It's a working of a 4-stroke engine. Okay, simple. It's a working of a 4-stroke engine. Now, it is just this slide I took for the. This is not required for you to write in the exam. Okay, I just took this for me to explain in a better way. Okay, right. Now, in engine management system, as I said, the requirement is to get a proper ignition timing and the entry of fuel into the system. Now, what are the activities which is been taking place in the 4-stroke engine? We have what is called as an intake stroke. The first one is called as the intake stroke. In that case, what has happened? The inlet valve is open. Okay. Now we call this as what? What is this point called?
Intake. Suction.
What is this point called?
TDC.
TDC. Okay, so this point is called as TDC, that is top dead center. This one is called as BDC. Okay, that is called bottom dead center. Okay, right. Okay, now in this case, the inlet valve is open. Now, once the inlet valve is open, the air fuel mixture will get into the cylinder and push the piston downwards. Okay, right. Now, in the compression stroke, what is that I am making? In the compression stroke, both the valves are closed. Remember, both the valves are closed. The air fuel mixture is being compressed. Correct? Okay. When the air fuel mixture is being compressed, what is going to happen to the charge here? The charge will, what is going to happen to the volume of the charge? Volume of the air fuel mixture, what is going to happen? Is it going to reduce or increase?
Reduce.
The volume of the charge is going to reduce and the pressure is going to increase. Okay. So once you are going to compress, the energy of the air fuel mixture will start to improve. Yes or no? When there is a larger amount of energy, what is going to happen? The spark ignition is going to occur. There will be a spark plug which ignites. After the ignition, what is going to happen now? What develops there? What develops there? What develops there? The energy develops that does what? That push the piston downwards. Okay, right. Now again, what is going to happen? The outlet valve has occurred, and you are going to send the burnt gas outside the system. Okay, right. Now observe carefully. In the intake stroke, what is happening? In the intake stroke, what is happening? The fresh charge is entering. Please understand. Fresh charge is entering through the inlet valve. Outlet valve is closed. The fresh charge push the piston inside the cylinder. The volume, you will take enough amount of the charge. Okay, so enough amount of the charge has been entered into the piston. At the end of the thing, TDC, so the piston moves from TDC to BDC. In the compression stroke, both the valves are going to be closed. Now the air fuel mixture is going to be compressed. When you compress the air fuel mixture, the volume of the mixture is going to be reduced and the pressure is going to be increased, by which a good amount of the energy is going to be present. Now, how do I spend that energy now? Okay, I'm going to spend that energy by igniting that energy. Okay, that ignition is going to be done by using a spark. Okay, now there will be a spark which ignites when the piston comes closer, because as you are going to compress, more energy, as you start compressing, more and more energy you are going to develop. Now when it comes to the spark generates. Okay, the spark generates and it will burn the gases, it will burn the air fuel mixture. Once there is a burn, okay, it push that energy will push this piston again from top dead center to bottom dead center. Okay, during this stroke is what is called as the power stroke, where when the vehicle is going to move, the vehicle is going to move in the power stroke. Then once it is done, then it comes down to BDC. From BDC to TDC, what has happened? All the charge has been burnt. Now what you have is you have the exhaust gases present. Now once you put the exhaust stroke, the exhaust gas, okay, is going to be sent out, okay, from the valve. Okay, so it's sent out from the valve. So this is the series of the operation which is going to be occurring. Okay, right. Now just observe now. Okay, if you are going to have a multi-cylinder engine, okay, if you are going to have a multi-cylinder, now this is for if you assume it's a single cylinder, this all thing is going to happen. Okay, right. If it is a multi-cylinder engine, what is going to happen? This process is going to be continuous. That means intake stroke, compression stroke, power stroke, exhaust stroke. Then one more has been connected to another cylinder. Okay, multi-cylinder. Then again the process is going to be continuous. Okay, you need to have the continuous process so that every time the power stroke is going to be present, which ignites the mixture with an expansion of the gas. Okay, that leads to the movement of the vehicle. Okay, right. Now with this basic understanding, now we'll move on to the block diagram of engine management system. Okay, right. Now in this engine management system, okay, now you can observe what we have. Okay, right. So we have what is called as the microprocessor based. This is a diagram what you need to do. Okay, the input is what? Engine speed, the crankshaft position, spark timing, feedback, engine temperature, throttle position, mass airflow. Okay, the output is going to be spark timing, air fuel mixture, and fuel injection valve. Okay, right. Now the engine management system, whatever we say, it is made up of sensors. Sensors are going to be there, actuators are going to be there, and microprocessors are going to be there. Okay. Now this system basically monitors and gather the data. Okay, this system monitor and gathers the data from various different types of sensors present in the engine and continuously adjust the fuel supply and injection timing. Okay, right. Now the objective of this the engine management system is to make sure, okay, is to make sure that, okay, there will be a proper ignition is going to happen. Okay, what in the proper ignition means? When the ignition should occur? At the beginning of the compression stroke, or at the end of the compression stroke, or at the middle of the compression stroke? Tell me, when the ignition, when the spark ignition is should supposed to occur? At the beginning of the compression stroke or at the end of the compression stroke?
Beginning.
Beginning.
Beginning of compression.
Huh? No, spark should ignite. Okay, there should be a spark. Spark ignition is going to occur. No, is the spark ignition is going to occur at the beginning of the compression stroke or at the end of the compression stroke?
End of the compression
Okay,
stroke.
obviously common sense, because at the beginning of the compression stroke, have you energized the charges? Yes or no? No, because you are not compressed. Okay, you have started to compress. Are you understanding? When you compress more, then the energy present in that is going to be larger. Yes or no? Okay. When you compress more, the energy is going to be larger. The expansion or the spark timing, the timing of the spark is very important, because if the spark is going to occur at this period, okay, at this period, if you assume that the spark is going to present here, okay, the spark occurs. Will there be any energy? There will not be any energy, and the vehicle will never going to move. Okay, because there is no energy. Now at this stage, what has happened? I have given enough amount of the charge here. Okay, there is a charge which has been thoroughly compressed. Okay, are you understanding what I am telling? the charge has been thoroughly compressed. When you compress the charge, you can understand, when you compress the charge, there is going to be larger amount of the energy is going to be present. Then at that moment, if the spark is going to be present, then it gives a better ignition. Okay, therefore, what the sensors are going to do? Okay, sensors are going to check. Okay, the sensors are going to check whether the a good amount of compression has occurred. Okay, because so that you are going to have a proper, okay, you are going to have a proper ignition timing. Okay, so you need to control the ignition. Remember, you need to control the ignition. What is that called as? The throttle position, okay, and the crankshaft position. Okay, so the crankshaft position and the throttle position is going to be monitored so that a proper ignition is going to occur. Okay, if the spark timing is going to be improper, then the energy obtained is not going to be met. Okay, that is one thing. Okay, that's about the spark timing. Then other one is going to be very important is what is the amount of the air fuel mixture which is coming. Okay, so the amount of air fuel mixture which comes to into the system should also be checked. Okay, so that you are going to have a better ignition system. Okay, right. Now steps are now basically how the process is going to be is important. Okay, right. Now in this case, the power and speed of the engine, okay, important, the power and speed of the engine. Okay, the power and speed of the engine are controlled by varying the ignition timing and the air fuel mixture. Okay, right. For a good spark timing to occur, you need to monitor the crankshaft position of the crankshaft and the throttle position of the crankshaft is important. Therefore, you monitor the crankshaft position accordingly, and at a proper crankshaft position, there is going to be an ignition should occur. Okay, so that information you are going to give to the microprocessor. Okay, the microprocessor will adjust the exact timing and gives the output. Okay, so accordingly you can make it up. Okay, so what the throttle position means? What is my throttle position? What for it is used? Throttle position is going to be used to make sure that enough amount of the fuel has been entered into the system. Okay, a proper amount of fuel has to be entered into the system, so that is going to be taken care by the throttle position. Okay, so this is something related to what is called as the engine. This is something related to the engine management system. Okay, right. Just remember, do remember this. The requirement of the engine management system is to make sure that there should be a proper spark timing to occur, and the air fuel mixture should be maintained correctly. Okay, now for this to happen, microprocessor will receive the inputs from the sensors and gives the microprocessor the feedback value. Depending upon the feedback received from the sensors, the microprocessor will adjust the crankshaft position accordingly so that the spark is going to occur at the right moment. Okay, if the spark occurs at the right moment, there will be a good amount of energy can be developed. Okay, so that adjustment is going to be done by the microprocessor as per the program what has been incorporated into it. Okay, right. So this is regarding what are called as the examples for microprocessor based control system. Okay, right. Now just observe here. Now if I just go back to the go back to this, can you able to see this? Okay, right. Now what is that we have done now is, okay, just observe now definition and introduction. Okay, this is modeling and simulation we have done, overview of mechatronic system, then measurement systems we have done, control systems we have done. Okay, then what I have just covered now is he has used the word called as simple controllers. That's all. Okay, why I am specifying this is he has used the word called as simple controllers. That is nothing but the simple controllers is nothing but what is called as the microprocessor based controllers. Under that, I have explained the three different types of microprocessor based controller. One is called as the automatic washing machine, automatic camera, and engine management system. Okay, right. Now next shall go for study of sensors and transducers. Okay, right. Now, in this study of sensors and transducers, we have just started earlier, if you remember. Advantages and implications. Okay. Okay, right. So this is something called as the simple controllers, microprocessor based controllers. Okay, again I am telling, in the exam I may give like this. Direct question I may give with the block diagram, explain the working of an automatic camera. That's one type of question. Other question may be with the block diagram, explain a sequential controller system. Are you understanding what I am telling? Yes or no?
Yes, sir.
If I say sequential controller system, you can write the example as automatic washing machine, or example taking automatic camera, or example taking engine management system. Okay. Rather than directly giving the example name, I may give like that. Or still I can still say that with the block diagram, explain with an example microprocessor based controllers. Okay, in that case also all the three is going to be present. Okay, because why I am telling this is, in each of the question paper, first once he is going to say microprocessor based controller, second time just to confuse he is going to say sequential controller, then some other time he is going to directly ask the name of the example itself. Okay, so in any of the cases, accordingly you just keep it up. Okay, right. Now shall we proceed?
Yes, sir.
Yeah, okay, nice. Then we have transducers and sensors. Okay, now this if you remember, is this part I have explained to you or not? This one, range, span, error.
Yes, sir.
Okay, right. I explained this. Yeah, I have explained this when I took what? When I took the measurement system. If I am correct, I have explained about the elements of measurement system. Yes or no?
Yes,
Yes,
sir.
sir.
In the elements of measurement system, what are the first component? What are the first component of measurement system?
Sensor, sir.
Sensors. Okay. At that moment, I explained these performance terminologies. Okay. So range, span, error, accuracy, sensitivity, hysteresis error, nonlinearity, resolution, stability, dead band, dead time, repeatability, response time. Okay. All these things I have explained. Okay. Right. Now let us start with the transducers and sensors. Okay. Take the heading as classification of transducers. Take the heading as classification of transducers. Okay, right. Now, before we go further, let me just say about the transducer. What do you mean by transducer basically? Transducers are the devices which induces energy change. Please remember, transducers are the devices which induces energy change. They will convert one form of the energy into another form of the energy. Okay, those devices which transducers are the devices which transducts the change. Okay, which transducts the change. Okay, that is called as transducers. Okay, now how the transducers are going to be classified? Okay, remember, the transducers are classified based on 6 different categories. Okay, transducers are classified based on 6 different categories. Now one by one we'll observe. Okay, so these are all the list of categories I am having. So one by one we'll go. Okay, first category is this: whether the device senses and converts or just converts the physical phenomenon. Okay, you can write depending upon the first classification is depending upon the sensing phenomenon. Please write this: depending upon the sensing phenomenon. Depending upon sensing phenomenon, transducers are classified as primary transducer and secondary transducers. Is it clear now? Clear? Clear?
Yes, sir.
Right. So now we'll understand what are primary transducer and what are secondary transducers. Okay, what are primary transducer? Now, the primary transducers are the type of detectors which sense a physical phenomenon and convert into an analogous output. Okay, right. Example is thermocouple. Just observe. You have what is called as a thermocouple here. Okay. What is the input to the thermocouple?
Temperature.
Temperature. Okay, the input to the thermocouple is the temperature. What is the output of the thermocouple? EMF. Okay, the output of the thermocouple is electromotive force. Okay, that means in case of a thermocouple, thermocouple, it senses the temperature and gives the output as EMF. Okay, this is called as primary transducer. Means what? What do you mean by this? In case of primary transducer, the output of this transducer is going to be obtained by one-time conversion of the input parameter. Okay, now here temperature, right? Temperature is converted directly into EMF. Okay, so that is called as in primary transducer. What are secondary transducer? What I will do is, I will take the EMF, I will send this EMF into one more device. Are you understanding? And process and get one more output. Okay, so that is called as the secondary transducer. Okay, so example I will give you. Okay, right. What are secondary transducer? These are those which converts the analogous output of the detector, which has sensed the physical phenomenon, into an analogous output. Means what? Observe this statement. Whether the device senses and converts or just converts the physical phenomenon. Okay. So in primary transducer, only one conversion. In secondary transducer, there will be 2 times conversion. Okay. So I'll just explain what it is. Okay. Now, in case of secondary transducer, now you have what is called as, have you heard of load cell? Have you heard of load cell?
Yes, sir.
Okay. What is load cell is used? Can you able to see this on your monitor? Can you see this on the
Yes, sir.
monitor? Okay. That's some diagram I am making. Correct, na? What is load cell? Any idea? What is load cell?
Transducer. Transducer.
Load cell is a transducer which is used for the measurement of force. Okay, right. Now, load cell is going to be like this. Just observe. What is the output of the load cell?
Electric signals.
Electric signal. The output of the load cell is the electric signal. Just observe. Just remember this. Okay. Means what is force? What is this parameter? Mechanical
parameter, sir.
Mechanical parameter. Okay. Now, in the previous, EMF has obtained from what? Directly from temperature. Yes or no?
Yes, sir.
Okay, good. In this case, okay, one more. What happened to that? Oh, it went on. Oh. Okay, right. Okay, so in sure. One second. Once again. Okay, right. Okay. Now, in case of your the load cell, so this is the load cell. Sorry, I don't know where it went. The load cell is going to be a cubical box. Now, to this cubical box, I am going to apply the weights. Right, observe. I am going to apply the weights. Right. Okay, right. Now, what is the load? Now, weight is nothing but the force. Yes or no?
Yes, sir.
Okay, right. When I am going to apply the weight, this is a stainless steel body. Okay. What is going to happen to this load? Force converted into what? What is going to happen to this member?
Compression.
Deformation, sir.
Compress.
Compression.
Member will compress. Simple. Okay. Now, upon the application, I'm going slowly. Upon the application of the load, okay, compression of the steel box or the steel cube is going to occur, by which an amount is going to be called as X. Okay. A strain is going to be present. Okay. Now the question is, I want to measure this strain. How will you do? How to measure the strain? How to measure this deformation? What is strain? What is strain? Strain is nothing but
Change in dimension to original dimension, sir.
change in dimension to the original dimension. That is called as strain. Now, if the strain is too large or too small here? Very small.
Small,
Okay, the
sir.
strain is very, very smaller. Okay. How to measure a small strain? What is the device used to measure a very smaller amount of strain? Any idea?
Strain gauge, sir.
Strain gauge. Very good. Very good. Okay. Now there is a device. Okay, or there is a sensor called as strain gauges, which is called as the micro strain gauges or simply strain gauges. Okay. Right. What I will do now is I will place the strain gauge at all the corners. One corner, one strain gauge. Another corner, one more strain gauge. Another corner, one more strain gauge. And another corner, one more strain gauge. Okay. What is the output of the strain gauge? The output of the strain gauge is an electrical quantity. Okay. What these four strain gauges is going to form? These four strain gauges will form what is called as, what is this I am writing? Four arms of what?
Wheatstone bridge.
Very good. It forms the four arms of Wheatstone bridge. So this is one. Okay.
Good
This is
count.
another, and this is another. Okay. Right. Now, when the electric potential is going to be there now, okay, right, with the change with the, if I give the electric potential, I'm going to have a what? I'm going to have a galvanometer which measures. Okay, now observe. Okay, right, now observe now. What is this called as? This is resistance R1, this is resistance R2, resistance R3, and resistance R4. Okay, right. Now you might have heard what is called as a balanced bridge condition. What is balanced bridge condition? What is balanced bridge condition? When R1 by R2 will be equal to R3 by R1, it is called as a balanced bridge condition. Okay, now you just observe what is going to happen. Now you applied the force. Please understand carefully. You applied the force. Due to the application of the force, there will be a displacement of the steel member is going to occur. This displacement is going to be sensed by what? This displacement sensed by what now? This displacement or the small deformation is going to be sensed by the electrical strain gauges. This is going to be sensed by the electrical strain gauges. Okay. Now, what these electrical strain gauges are made up of? These electrical strain gauges are made up of four arms of the Wheatstone bridge network. Okay. Now, when there is a strain, what is going to happen to the resistance R1? Earlier it is going to be R1. The resistance of this is going to be changes. Yes or no? Yes or
Yes, sir.
no? If all the resistance are going to be same, that is R1 by R2 is equal to R3 by R4, that is a case of balanced bridge condition. With the application of the load, the resistance changes. When this resistance changes, what is going to happen? Due to the change in the resistance, there will be change in the electrical signal is going to be occurred. Okay. Now this electrical signal is the output of what is called as the load cell. Okay. Now you just try to understand. Now the question now is the electrical signal what you have obtained, which is the final output. Have you obtained directly converting weight into electrical signal? Yes or no? Is the electrical signal as obtained directly from the weight or the force? Yes or no? Are you understanding or what?
Yes, sir.
Okay, no, this electrical signal, this electrical signal you obtained, no? Okay, you have got some voltage now, correct or what? Is this voltage is obtained directly from the force?
No, sir.
No. Okay. It was not obtained directly from the force. What has happened? Force has converted into
Electric.
displacement or the deformation. This deformation has changed the resistance of the Wheatstone bridge network, due to which the EMF has been developed. Are you understanding? Now, this is called as example for the secondary transducer. That means in secondary transducer, in order to get the output, the conversion is going to occur at two instances. Now, which is the primary transducer here? The primary transducer is the load cell. Are you understanding? The primary transducer is the load cell, which converted force into deformation, and that deformation as sensed by the strain gauge. Due to the change in the deformation, the change in the resistance occurred. Due to this change in resistance, the electromotive force has been developed. Hence, this concept is called as the example for a secondary transducer. Now observe, okay, in primary transducer, okay, the conversion is going to occur how many times to get the output?
One time.
Only one time. Okay, in the primary transducer, to get the output of the transducer, conversion is going to occur at only once. But in secondary transducer, in order to get the output of the transducer, the conversion is going to occur at two instances, one in the primary transducer stage and another in the secondary transducer stage. Is it clear now? Okay. So these are the examples of what are called the primary transducer and the secondary transducers. Okay, right. Now, basically, this is about the first case. Okay, the first case of the transducer, what we'll be having. Okay, right. Now, okay, right. So this is about the first case of the transducers. Okay. Now, with this, the first case, I think we can move ahead for the second case now. Okay, one more example I can able to give, that is called as what is called as this. Okay, now if you observe, now what is this? Can you able to just see and tell what is this? Don't read it. Don't read the figure there. I have written here clearly. What is this? What you have here? What is this? What is the left one? What is this actually? What is this? This is the
Bourdon tube.
Bourdon tube. Okay, so Bourdon tube converts what? Converts pressure into displacement. Correct. Which is the primary transducer here?
A Bourdon tube, sir.
Bourdon tube is the primary transducer. Okay, now what is this
Bourdon
displacement?
tube.
The displacement I have connected to what? I have connected this displacement to the LVDT. LVDT is what? LVDT is linear variable differential transformer. Okay, so I'll just explain. Okay, maybe the time is up, I think. Okay, I'll just check whether sir has come. Okay. Okay, right. Now he's going to join. Okay, now this is about what is called as, I'll come and explain. Okay, so maybe it may require some time for me also to explain. In that case, okay, in the case of your the primary transducer, again I'll consolidate. Okay, so primary transducer is the one wherein to get the output, the conversion is going to occur at only once. Okay, that is called a primary transducer. And in the secondary transducer, the conversion is going to occur at twice. That means the output of the primary transducer will be taken, okay, as the input to the secondary transducer, and that processed and converted into the secondary transducer. Okay, so that is the case. Now, in the example, that is what I have told, okay, which is with respect to what is called as your the Bourdon tube. Okay, so Bourdon tube. Now, in that case, the Bourdon tube does what? The Bourdon tube is a primary transducer. Basically, the Bourdon tube was the primary transducer, and LVDT is going to be considered as the secondary transducers. Okay, right. So now I think we'll stop at this stage. Okay, I'll stop at this stage. Now the you'll be in the same link. Okay, so SS is going to come. Okay, SS is going to start with his class. Okay, right? Is it clear now? Right? Okay, right.
Yes,
We'll start. Okay, I think SS has joined now. Okay, right. So we'll stop at this stage. Now you'll be in the same link, and tomorrow again we'll follow the same link throughout the semester. Okay, so it's easy for everybody to follow through. Okay, right. SS.
Yes.